Once you have a firm grasp of what slope is, you can use it to help write equations that can answer questions. First, you must understand the difference between a dependent and an independent variable. In this example, I had two things that varied: the number of calories that I was burning and the time that I was running. When I graph these variables, I ask myself, did the time I ran depend upon the number of calories I burned, or did the calories I burned depend on how long I ran? Because the calories burned depend on how long I run, the calories go along the y-axis, and the time is on the x-axis. In the second example, the calf's weight depends on how long he has been growing. The weight belongs on the y-axis, and the age of the calf lies along the x-axis. Let's revisit this example and write the given information as ordered pairs. Since the age of the calf is the independent variable, it is the x value of the ordered pair, and the weight, or the dependent value, is the y value. Our two ordered pairs become 30 days, 190 pounds, and 45 days, 235 pounds. The rate of change, or slope, for this problem is the change in y, the change in the weight, over the change in x, the change in time. So when we subtract this, 235 minus 190 is 45 pounds in change, and he's become 15 days older, which reduced to 3 pounds per day. The slope y-intercept form of a line with a slope of m and a y-intercept of b is y equals mx plus b. That means that if we know the slope of our line, 3 pounds per day, and we know the y-intercept of our line, where it crosses the y-axis, then we can write an equation for this line and use that equation to predict things. For this little guy, y equals 3x plus, where does it cross the y-axis? 100. So what does that 100 mean? Well, it means at time 0, his age and month of 0 months, in other words, when he was born, he was already 100 pounds. And then every day, he grows at an average rate of 3 pounds per day. The nice thing about having an equation is that we can predict how much the calf will weigh when he's 3 months old. We're looking for the weight, y, and we know that it grows 3 pounds per day. 3 months old would be 90 days, plus the 100 pounds he weighed at birth. So y will equal 270 pounds plus the initial 100 for a total of 370 pounds when he is 90 days or 3 months old. We can also predict when he will be 750 pounds, which is when many calves are sold to a feedlot. 750 pounds represents the y in this case, and it will be equal to 3 times some number of days plus the original 100 pounds he weighed at birth. So if we want to know when will he be ready for the feedlot, we take away the 100 from both sides to get the 3x by itself, because it was added. The opposite is subtraction. 650 is now equal to 3x, and if we need to, we can break out the calculator and say what is 650 divided by 3. And our result is about 216 days, which is just over a little over 7 months. In this example, a bride is trying to grow her hair out to be 12 inches long for an updo on her wedding day. So if her hair is 5 inches long now and grows at a rate of a 1/2 an inch per month, how long before it's 12 inches long? The hair depends on how long she's growing it. The number of months is on the x-axis, and the length of the hair is along the y-axis. How long is her hair at the beginning? 5 inches. And it's growing at a rate of 1/2 an inch per month. So after 1 month, it will be a 1/2 an inch. After 2 months, it will be a full inch longer, and so forth. So we're trying to determine after how many months long will it be 12 inches. So let's put this into an equation and solve it. Our slope y-intercept form of our equation is y equals mx plus b. So y equals m, 1/2 an inch, times x, plus our original value, b, which is 5. We want to know after how many months will her hair be 12 inches long. So substitute 12 in for y, and then get the 1/2 x by itself by taking the 5 away from both sides. So 7 is equal to 1/2 of an x. If we want to get the x by itself, the opposite of multiplying by 1/2 is multiplying by the reciprocal, or 2. But if I multiply the right side by 2, I need to multiply the left side by 2, and 14 months is our answer. Here's another example of using slope. On Halloween, Nicholas had 258 pieces of candy. On November 5th, he had 232 pieces left. If he continues to eat his candy at that pace, how long will it be before he runs out? One strategy here is that we can write these as ordered pairs. So on Halloween, the very first day, he had 258 pieces. On November 5th, after he had been eating candy for a total of 6 days, he had 232 pieces. So we can use these two ordered pairs to figure out what our rate of change is in his candy. We had 232, the second y, minus 258, the first y, over the second x, 6, minus the first x, 0. So 232 minus 258 is a total of 26 pieces of candy that he's eaten in that time frame, in the 6 days. That reduces to 13 thirds. So about 4 1/3 pieces of candy a day is what he's averaging. So let's put this into the slope y-intercept form. Y equals mx plus b translates into y equals 13 thirds times x plus b, his original candy amount. And I made a mistake here. 232 minus 258 is a total of negative 26. So negative 13 thirds, which makes sense because his candy is decreasing over time. And his b is his original amount at time 0, where does it cross the y-axis? When x is 0, y is 258. So we want to know if he continues to eat his candy at this pace, how long will it be before he runs out? Well, he runs out when he has 0 candy left. So we set that equal to negative 13/3 times x plus 258. Getting this negative 13/3 x by itself, we have to subtract 258 from both sides. So if negative 258 is equal to a negative 13/3 times x, I'm going to multiply by the reciprocal or divide by negative 13/3. So 258 of the negative variety times 3 divided by 13, again of the negative variety, will get us our number of days before he runs out. So 258, negative times a negative is going to be a positive, so we'll take that times 3 and then divide it by 13. And Nicholas will run out of candy at this pace in about 60 days, or just before the New Year's. Here's one last example. We have a farmer who's harvesting his corn. He had 2,000 acres of corn and has already harvested 480 acres, and his combine can harvest 12 acres of corn per hour. How long before he finishes combining? So let's start with our equation, y equals mx plus b. And let's put the correct values in for m and b. The change is the acres of corn per hour, so that is our m. And our b is the number of acres that he has already harvested at time 0. So we want to know when he will finish. We're going to substitute 2,000 in for y. All of his acres will be finished. So all of his acres will be finished with this when this equation is satisfied. So let's get the 12x by itself by subtracting 480 from both sides. So 2,000 minus 480 is equal to 1,520. So if 1,520 equals 12 times x, we divide by 12, and we see that it's going to take him about 127 more hours.